I think just we can move to the next slide, which is on data science. So talking about data science, we've broken into four parts. So let's first talk about statistics and how important is the maths involved behind algorithms. Like considering the fact that there's so many libraries available, is it really important to understand the math that goes behind the algorithm, or it's fine if you even don't know it?
So one thing I've learned at CMU, being a core data science college, is math is something that's the background of, like, the backbone of any kind of data science or machine learning model. Now, data science is a big picture. It's not just machine learning. It's a lot of other things as well. Like some of the things are mentioned on the screen. So math is one piece of it. So for example, when you build a bridge, you make sure that the pillars can, take the weight of all the cars or all the people walking on it. So that's, if that fails, the bridge will fall. That's same thing with data science. So math is like one of the most important pillars. I've spoken to Nida ma'am and Meghna ma'am, and I appreciated every time they taught me math, is because math is something so intrigued and so involved in data sciences that you cannot escape without it. So if you don't like maths and you want to get into a data science, I would say take a halt, make a conscious decision. The reason being, there, as you mentioned, there are a lot of libraries that people can use. So, for example, I was working in the startup who was working for autonomous driving. So my role was to detect objects, like like when you scan a particular area around the car, who are the people, who are the cars, what is the speed, and those kind of things. So for these kind of things, there are already online sources, PyMate search, and blah blah blah, who have ready-made libraries that you can detect objects, but with what accuracy, with what speed. And once you use this existing model, how do you tweak this model to make it more accurate? Because for a bank, to detect frauds, if you have, let's say, 85% accuracy, and you're doing your KYC, you're taking, let's say you're taking criminals in, you're opening their accounts. So regulations come into place. They will charge you with a lot of, penalty if you're giving benefit to these kind of things and letting fraud happen in through your organization. So because you play a part of it. So just this is just one example. So for example, the other piece is Amazon. when they are um, when they are giving you suggestions, if you have bought this, you like this. So for example, bread and butter goes with each other. Now if people who buy bread more, they also buy eggs. And in Walmart, for example, the most recent finding that they had, not most recent, last year that they had was, people who buy diapers are also buy beer. That's something that they found out through data. That's something that nobody would, everyone would say, what crap. But that's something that they found through the data, and data doesn't lie, right? If you have the right data. So what they tried to do, and what every Walmart in US did, was keeping the diapers next to the beer. And you see, when you go to DMart, Big Bazaar, Reliance, you see those fridge, and the most important pieces that you need will be at the extreme corner, extreme end, as soon as you enter. So for example, if I'm going for shopping, I may go for, getting the veggies, which will be right in front of me. But to get milk or to get eggs or anything else, I have to go further in. And as I walk towards it, I see a lot of 100 other items. And those are the items that are not, giving a high sale. And people end up buying it. So that's how you increase sales. So that's the important piece of data science models. And you can only get that knowledge if you know the math behind it. Again, machine learning model is something that you can use right away from online libraries. There's sklearn libraries. You just have to write one line. If you have the right data, you just have to write one line code to, build your model based on that data. But if the model is not giving the right accuracy, precision that you need, if it's not sensitive to negative points, and if your data is biased and those kind of things, your machine learning model will fail. So It's not that, I just implement a machine learning model and it's done. Implementation part is just, 5% of the job. The 95% of the job is cleaning data, doing that data, building those trends, doing those statistics, which involves a lot of math, keeping your data unbiased, which means, let's say I'm detecting, cancer tumors within different patients. Now, the number of positive connects that I'll have will be less than 1% people get it, right? And if I do a survey, I may not find out anyone who had a cancer tumor or something. So if I don't have that data within my data piece, which feeds into the data science model, my system, what is it going to predict? Like if I have just one entry out of thousands entry, my model will definitely fail if it sees something else. So that's the important piece of statistics and maths. The visualizations is important because so I work a lot on visualizations and the algorithms, which is part 2 and 3 over here.